Alright. This last major part to review before the final are two pieces, complementary functions and their values, as well as rewriting trig functions. Both these are relatively short, very formulaic pieces to have for today. The formulas will not be given to you. They will not be up there. Both the unit circle and my grail will be taken down. You are expected to know these formulas. These are the basics, okay? Now, as for they fit together, let's go ahead and talk about the two big parts, complementaries and rewriting. So, in the last week, we have discussed each part that's going to be on our final in depth a little bit more, just to make sure we're all stable on those. Yesterday, I had a little video showcasing how to do the direct and indirect use of the trig functions. I hope you took a look at it. I hope you took the homework from yesterday. That was your last homework assignment. There will be no homework tonight.
Homework.
The last homework assignment we posted last night.
Are we going to get a review sheet?
Yes, you will.
Okay, great.
The review sheet will be your last grade besides the final itself. So, make sure you take a look at it. And that review sheet will be essentially the same as the quiz we took like 2 weeks ago. Because you're finalists in one of that quiz. So, the only difference will be, remember, for the final, you need to have the unit circle fully memorized. No notes allowed. No piece of paper on the wall waiting for you.
That's the whole final itself.
Alright, let's start with complements. For each trigonometric function, there is a complementary function to go with it. A complementary function means a way to rewrite that function as a different function by undergoing a very specific change. So, let's take a look at our 6 trig functions and look at their complements. Sine of theta, cosine of theta, tangent of theta, and we have our next 3, which are cosecant of theta, secant of theta, and cotangent of theta. Now, the nice thing is, you can verify these using a calculator very easily, because these formulas are relatively simplistic in how they work. Now, I'll write these in a unique way to showcase kind of how they fit together. To do these problems, I will showcase both the radian and the degree version in the same formula. Here we go. Sine, cosine, tangent, cosecant, secant, and cotangent. Here we go. Sine is equivalent to cosine with the following change. That change is you either take 90 minus theta, or you take pi over 2 minus theta. So as an example, thank you, Bell. Sine of 17 degrees is equivalent to cosine of, what is that, 73 degrees? Because that is just 17 subtracted from 90. This is a natural consequence, and you can verify with any calculator that does trig functions. Type in sine of 17, type in cosine of 73, they will be the same as long as you're in degrees. Again, as long as you are in degrees, they will be the same. Cosine is equivalent to sine with the exact same 2 changes. Either you have 90 minus theta, or you have pi over 2 minus theta. So sine is equivalent to cosine after one change. Cosine is equivalent to sine after one change. So, in this example, you might say something like cosine, let's see, what's a good example? Let's see, pi over 3 is equivalent to sine of pi over 6. You get that very simply, if you can, by using the fractional rules. You can also get that by converting it into degrees and then converting it back into radians. But those 2 statements are true. Grab a calculator and show it. Cosine of pi over 3 is equivalent to sine of pi over 6. Tangent is equivalent to cotangent after the change. So tangent is equivalent to cotangent after the change. Again, easily verified. Just grab the formula, grab a calculator, you can do it. Cosecant, secant, and cotangent follow the same basic pattern. So cosecant is equivalent to secant of those two categories. Secant is equivalent to cosecant of those two categories. Cotangent is equivalent to tangent. So, you notice that all of these fit similar forms because that's how these complements are designed to work. They all have the 90 minus theta or the pi over 2 minus theta in them. So they're designed to work that way. And the nice thing is, these are super simple. Even if you don't necessarily have the formula memorized, as long as you remember which one it is, a calculator will tell you the rest. Try out different numbers in the other trig function and see when you can make them match. These are the 6 basic formulas. And these are referred to as complements or complementary trig functions. Meaning it's a way to change one trig function into another trig function by modifying the number inside of the trig function. So if I don't feel like using sine, I can use cosine. I don't feel like using cosine, I can use sine. Again, the trickiest part, in my opinion, about your final is that there's different pieces that look very similar. There's like 4 parts that all use trig functions, but some just want you to find the trig ratios. Some want you to use the trig ratios with a calculator. Some want you to use the trig ratios with a triangle. Some want you to combine the two together. It's a lot to think about. So make sure you get them straight. Eric, you're on time. It's 11 first.
Oh, I was actually early.
I was just making a tip. Okay. These are a lot of formulas. I'll do a couple real quick examples, but these are not hard arithmetically. They're hard because there's 6 formulas, and you've got to get the right ones to put together. So let's look at a couple examples here. Let's see. I want you to determine the complement that gets me from cosecant of 21 degrees into secant. What number needs to go right there? I want you to tell me what value for cotangent of pi over 7 gets me to tangent. I want you to tell me what sine value of 38.5 degrees would get me a cosine value. Can't chill, won't chill.
So is this like
Think of this as examples to help you get ready for tomorrow and for.
I got a question.
Yes, sir.
Where's the cosecant button on the calculator?
There isn't one. But remember, you can always, instead of using cosecant, 1%. And secant is 1 over cosine. And cotangent, 1 over tangent. You can, if you want to verify that you're right. Again, think of this first one. I'm going to plug this first one into this cosecant equation right here. Since I'm dealing with a degree, I'm going to use the top version, which says 90 minus theta. So what I'm going to take in here is going to be 90 minus 21. 90 minus 21 would be 69 degrees. Now, how is it helpful? Well, I can easily check that. I can type in cosecant of 21, I can type in secant of 69 degrees, and see if they do in fact match. Now, to do that, I should always double check that I have my calculator in the right form. So in this question, the correct answer is the secant of 69. Because that is the complement to cosecant of 21. And I'll prove it. Here's my calculator. Desmos is nice enough, that's why I recommend it to a lot of people, that it will actually be able to, stupid website, do it the hard way then. Desmos will actually do the math for you, which is super convenient, and it has all the trig functions already put in. So if I want to do, for example, cosecant of 21, I want to make sure it's in degrees. For these calculators, I have to hit this button. Nope. How do we do it in here? Settings? Nope. Where is it? On here? Wrench. Okay, make sure I'm in degrees. There we go. So it says cosecant of 21 is 2.7904. Beautiful. So I want to check that. So I type in secant of 69. And they're the same. So I know I did it right. If I don't have one of the fancy like calculators that has all 6 trig functions, I can do the same thing using a standard calculator.
Is there one out there that has all of them?
I've only ever seen one. And it's like a $300 calculator.
Oh,
So personally, would I buy that? Never in my life.
yeah, I would. Make it easier.
So I would do 1 divided by sine of 29. I want to make sure it's in degrees, so I have to switch that.
Oh, it's S money links over there.
So go to degree.
You just flip this. Use that money. For what?
Okay. So 1 over sine of 20. Oh, it's 21. Dang it. 1 over sine of 21 is again 2.7904. 1 over cosine of 69 is the same thing. So any calculator that does it will do it for you. And again, it's about finding that complement. 21 and 69 happen to be complements. Up here, pi over 7 is complement. Could be found by taking pi over 2 minus pi over 7.
Tangent of pi over 2 minus pi over 7, right?
Yep.
5 pi over 14.
So this one is weird. It is 5 pi over 14. 14. Someday I will write a 4 correctly. 5 pi over 14 is a correct solution. But again, I can verify that pretty easily just by typing it in. Do they actually match? Sine of 38.5 is equivalent to, again, I would take, this is in degrees, 90 minus 38.5. 90 minus 38.5 would become 51.5. And that would be your solution.
What? How did I get that?
Oh, so now, that's good. That's good. So now you want to check that by taking in tangent of.
That was tangent. Yeah, I did.
Oh, so we're really so it'd be 1 divided by 10 or 1 over 10 of.
But I thought if you just typed it in there, it would give you 5 pi over 14.
If you want to get the answer, don't type in tangent. Just type in pi over 2 minus pi over 7.
Yes.
And it'll give you 5 pi over 14.
Yes.
So that's saying tangent of 5 pi over 14 is equal to cotangent of pi over 7.
Correct. You also degrees, and there's more fun. Okay. Did you cook more just to make sure we're solving this? Reminder, the number on the inside is the solution. That's it. That's the entire solution. It's what makes it a complement. Let's do 3 more. So I got cosecant, I got cotangent, I got sine. 3 more. Let's do tangent. Let's do secant. Let's do cosine. All right. A number that goes into tangent. Let's do 2 pi over 5. For secant, let's do 79 degrees. For cosine, 12 degrees. I don't like 12. 32 degrees. Okay. Tangent is equivalent to cotangent, but what number goes inside? Secant is equivalent to cosecant, but what number goes inside? Cosine is equivalent to sine, but what number goes inside? Again, it's about finding that separate value, that complement, that gets you the same solution, but is clearly a different value. So the first one, I use my formulas. My formulas again are right here. Tangent to cotangent. What I got to do is subtract pi over 2 from the angle. So I do pi over 2 minus 2 pi over 5. It is pi over 10. That pi over 10 is your only solution. It is the number for cotangent that is equivalent to the tangent value. For secant, 79 degrees is equivalent to 11 degrees. We take 90 minus 79. 11 degrees.
58.
Cosine of 32 is equivalent to sine of 58 degrees. That number on the inside is the only solution. The value at which these two functions are equivalent. So, this is an important distinction to make. Wrapping together all the components we talked about so far this year. Coterminals are the same angle for the same trig function. So 328 is equivalent to a bigger number and a smaller number for sine. A bigger number, smaller number for cosine. For tangent. Only the three. Reference angles get us an equivalent value. Again, using the same trig functions. Complements are the only thing we've talked about so far that allow us to switch between trig functions. If I don't like secant of 79 degrees, I could use cosecant of 11. If I don't like sine of 38.5, I could use cosine of 51.5. Like, it allows us to take a single trig function and change it to a new trig function that should be equivalent. It's the only thing we've talked about so far that lets us do that. Questions? Then the last part of our notes. We're finished. There are 6 trigonometric functions, but there are ways to write some of them alternatively. Let's look at those 6 one last time. Sine, cosine, tangent, cosecant, secant, and cotangent. Now, these first 2 are locked in stone. They cannot change. They are defined. You could think of them as parts of a triangle using O over H and A over H, but there's no way to rewrite them any other way besides sine and cosine. Tangent can be written as opposite over adjacent according to the basic formula, but there's actually another way. Tangent is equivalent to sine divided by cosine.
That's tangent?
Yep. And you can verify that. Pick any number you want, plug it in for tangent, and then take sine of that number divided by cosine of that number. They are the same.
Oh, wrote it on the wrong spot. Oh.
There are questions on a quiz that said to rewrite these in terms of sines and cosines. This is what it means. Tangent can be rewritten as sine divided by cosine. Cosecant, I've already mentioned once today.
Do we have to remember these?
There's 1 over sine. Heck yeah, Levi. Secant,
I can't remember.
1 over cosine.
I thought we were.
Cosecant and cotangent.
I'm not excited.
Nice thing is, Levi,
Yeah.
once you pass these quizzes, next semester you get one of these. And you get to use it for your tests. Get them all written down. You gotta do it once, like everybody else. We all suffer that one time. You gotta memorize them for the test. This will be like the second week of January is when you get this. And it's nice. Very nice. It gives you a bunch of formulas that you'll look at. Beginning of the year, you're like, what? What? And they're like, it's later.
Are we gonna be able to use it on the final?
Yeah. That's the only thing you're going to use in the final of the year. Yeah. Yeah. It's so tiny.
But helpful.
It's so tiny.
Well, we don't take finals in the year for here, do we?
Still quite a minute.
If you take it, I'll do it.
Okay. These are the components you need to be ready for your final. Notice there are a fair bit of formulas, but they all kind of fit together pretty well. The complements just convert sines into cosines and cosines into sines. Tangents into cotangents, cotangents into tangents. These ones are the weirdest ones. but these are also the shortest part of your test. These tend to be ones where either you remember it and you write it down in 2 seconds, or you don't and you guess and move on. So, in total, we have reviewed all the pieces we had for our final. Tomorrow, you'll receive a review assignment.
We had this class on Monday, or
We'll have it all every day this week.
well, yeah, but like on Thursday, right?
Our final will be on Thursday because we're not on block.
What do you do that?
Personally, I'm thinking on Friday we do some fun.
Yeah.
I was personally thinking about making snowboards.
Oh,
You know, be a little artistic. Yep, just craft snowflakes.
I've made a snowflake and
I don't know about that. That's kind of like.
you're lame.
Let's do like an engineering thing. Or something.
Well,
Yes.
what I could do is, I can make craft snowflakes, but they have to have math symbols on.
Ooh, cool.
Not so good? Not good? That's good? Too bad.
That's too bad.
We can make math themed Christmas ornaments. My beautiful Christmas tree in the back is naked. And sad. Has a mouse trap on it.
So we're not gonna work.
Nope. Have your review assignment tomorrow? Yes, ma'am. Sure. You had, what was it, 7 problems from yesterday?
I worked yesterday.
No, it was
I
9
didn't
problems.
even look at it.
Was it 9 problems?
It was 9.
You know, when you said that, I'm like, oh, he's being sarcastic. So, no, I'm sorry. If you just posted the homework, I would have done it. But I mean, if he's... I just saw
Yeah.
the part when he said, ha ha, you think...
So I said, haha, I'm like he's joking. That means there's no homework. So I didn't even open it.
No, the joke was you thought there wasn't homework.
Exactly.
So I
What
didn't
question
do
was it?
Number 4.
Cool.
And,
It's due tomorrow, right?
Yes.
Oh, it's due tomorrow?
Yeah.
It says on the thing.
I wasn't paying attention. I just thought
I
it
could
was
tell.
easy. I just didn't
Don't
know.
fly.
Fine. I'm
Alright.
gonna turn it
Come on.
in. Is it due tomorrow? This is due tomorrow, I think.
Oh.
I feel like there's an echo. It's weird. Alright. 15 you said? Oh, no, I don't want to open that. No, I don't want to open that. No, not the video. Why did it say GIF? That annoys me.
It's a gift.
Which 15?
Hey, London. Send that stuff to Pierce.
Top 15?
The paper.
I already did what I have of it.
I hate it when you play both sides.
This is the only one where you don't have to do 2 triangles. Like, you see 16, same basic thing. Ready?
So
Get the following. 1 triangle.
you're gonna be such a bad snorer.
A, B, C. And what does it say? Little a is 5, so that's the side across from A, so I'm going to put a 5 right there. Angle A is 60 degrees. 60 degrees. So we got missing side. I'm going to call this one little b. And this one little c. Ready? So, in this picture, don't forget, in any triangle picture, there are 6 trig functions I could talk about. Now, I'm actually going to list 3 of them. Sine, cosine, and tangent. Because in any triangle, I can always do that. Ready? Sine. Sine of 60, because that's the angle in question, is the opposite of 65 of the hypotenuse, c. Notice sine of 60 is a number. 5 is a number. C is a variable. This is a good setup for us to do this problem, because I should use a calculator to do sine of 60. I can do the same thing with cosine. The problem is cosine is not very good for this, because I'd get b over c, and that's not good. 2 variables, not good. I can also do tangent of 60, which would be 5 over b, which again, a known value from a calculator, a known value from the problem, 1 variable. I could solve this with a calculator very easily. Okay. So I'll go ahead and let you do it on your own if you want. And it's the same on 16 as well. They're the only 2 that do not require you to have an actual
Right.
second triangle. Just because you don't need the trig ratio, you can get the trig ratio yourself. The previous ones, they gave the trig ratios. This one isn't even requiring that.
Cool, you want some hunting this weekend?
Any other questions on homework assignment?
I'm done.
Me and my dad are probably gonna go.
Yes, ma'am.
We come over on Friday night.
That's okay.
Which one?
Friday night we play Ag Rabbit.
Yeah, I'm
I'll
done.
stop the recording. Just kidding.
See if I come